Thank you so much, Lori. Welcome everybody to our webcast this afternoon, this morning, wherever you might be. Today's webcast, just to get some some slide decks out of the way, the obligatory slide decks is brought to you by IMAGINiT, the company that I work for, IMAGINiT Technology. We're an umbrella company. We're part of an umbrella company called RAND Worldwide, which includes our RAND 3D sister company and the Ascent folks, the folks who make our courseware. So I'm glad to have you on board. We're going to talk about a very cool new subject this morning with related to the world of manufacturing, additive manufacturing. But first, let's get started with talking about kind of why, the direction we're going, why we're showing this kind of stuff. And it all boils down to standardization, right? It all boils down to one technology, using a single source of technology, standardizing to make things happen more efficiently. So traditionally, manufacturing thrives when we can share data and when we can share workloads a lot easier, and we can automate things that are, that should be automated, and really simplify management of complex processes. And everybody's looking for ways to standardize on, all practical objectives within the manufacturing environment. When you do standardize, it does things like address the skills gap. You got best practices that can be captured, and you're not relying so much on tribal knowledge. Efficiency of process is you just basically replacing standalone stuff that's out there and prevalent all over the manufacturing world, and integrating systems to eliminate any redundancy. Yeah, lots of companies, lots of clients we talk to are using different processes for the exact same end game, right? So why not get this all set up to add toward the simplification of everything, streamlining your training, your support, your onboarding, your management, the whole works. That's what this is all about. And of course, why Autodesk? Well, let's take a look. So for 35 years, Autodesk's mission has been to address what they refer to as the future of making things, right? They've done a lot of research and a lot of development into how manufacturing is going to be. It's not just the AutoCAD company anymore. Huge investments have been made in, world-class, best-in-class technology that includes things like mold flow for predictive analysis, Algor. Well, the product we're going to start talking about today that's integrated into Inventor and Fusion, it used to be called HSM. All these things are huge investments in Autodesk's initiative to become a go-to resource for end-to-end manufacturing technology. And it involves all phases of manufacturing, from the planning stages through the programming and development, how you're gonna set things up for different additive and subtractive machinery and equipment, and then produce. The make part you'll hear me refer to quite a lot. And it all involves a plethora of technology that Autodesk now gives to or makes available to their clients, right? And again, we're right there. We're going to take a look at the Autodesk HSM technology, the CAM environment, which is kind of in the program. But I don't want you to forget, and I want you to ask about how we play in other aspects of it, whether we're talking about Feature Cam, Power Mill, whether we're talking about NetFab at the very beginning or at the very end when we're talking about nesting and capabilities that Fusion has from there. And this is all done with a giant investment. Autodesk has over 600 software developers from the manufacturing engineering world, all dedicated to all of this technology. They've invested over $1 billion. They've even invested in these manufacturing innovation centers all over the world, so they can actually do manufacturing and sort out the issues and optimize the technology that they're offering through real world scenarios. And they're doing this with the help of 40 partners, what we call make partners globally, and IMAGINiT is one of those. In fact, we're Autodesk's largest integrator throughout North America, and one of the largest make partners in North America as well. Today, we're going to talk a little bit about, of course, the manufacturing process, the CAM tools that are inside of Fusion and Inventor. Now, this slide deck typically refers to Fusion, but that's okay. The CAM environment exists and is very similar between the two, and is being developed equally between the two, right? So when we talk about one technology or the other, we don't want to forget about folks who may be adopting Fusion 360 as a cloud-based strategy, using the generative design technology to come up with new innovative designs for emerging markets, lightweighting, constraint for stress, all those types of things that lets AI predict what the part is going to look like. We're also talking about Inventor from there as well. All of this involves, a technology that can be enhanced even further. So if you want to take this to the next step, you're going to see some stuff that Nathan is going to do for us this morning. It's pretty impressive. But if you want to take it a step further and again, working toward that standardization of process and start talking about things like feature recognition, nesting automation, intelligent automation that takes workflows that are repetitive and captures that design. For example, we can have our technology look at a hole, understand the diameter, the depth, and the material, and pick out the correct toolpath, workflow, process, whatever you needed to do to address that feature, and not have to have an expert on hand to make that decision up front, right? So it's all kind of captured, and various ways of getting that done, various ways of doing that. So we're happy and eager to talk to you about this process and workflow. I don't want to spend a whole lot of time on all of this, because I know you guys came here for the picks and clicks session of the demo that Nathan is going to present. And just as a quick intro, we're going to talk, I know this is called milling. We're going to talk about milling inside of Inventor, but we're going to use Inventor and Fusion for a couple of things. We're going to do some multi-axis machining on the part that you see on the left, and then we're going to talk briefly about some turning operations on the part that you see on the right. So these are the two fairly typical concepts, fairly typical geometry that you'll see used inside of the CAM environments, inside of our technology. So with all of that, I am ready to hand things over to Nathan to talk about using the CAM environment within Inventor and Fusion. Are you ready to share your screen, sir?
I'm ready.
All right, I think you can grab it. I don't think I have to.
Let's see here. See,
maybe I need to change presenter here.
Yeah, go ahead and change the presenter.
There you go. There you go.
Can you guys see me?
Looking for where? I don't see you yet, Nathan.
Let's see.
Have you hit show screen?
There we go. How's that?
Not yet.
There we go.
Oh, there we go.
Seeing you now.
All right. Good deal. And kind of move this out of the way if I can. All right. Well, thank you for joining me, everybody. I'm going to kind of take you through the HSM CAM workspace as well as Fusion. I'm going to start out in the Inventor HSM, and then we'll move on into Fusion. I'll show you some multi-axis CAM strategies in there here in a little bit. And I really want to kind of show you the similarities between the two, but also how they're different. So starting out in Inventor HSM, Inventor is more of your traditional integrated CAD/CAM software. So in the modeling section, we can kind of see we've got our basic workflow and our feature tree down here, where we can see a lot of our parts being made, our parts being designed right here. And the big takeaway from Inventor HSM and Fusion is that it really works in conjunction with the CAM environment. So any kind of changes we make to our design and our geometry, we can it'll automatically update our toolpaths in our CAM. So starting right here at the top, well, actually, I'm going to go right here into our 3D modeling. In Inventor, we have our full 3D modeling suite. So any design changes we want to make, any kind of sketches, annotation, inspection, it's all right here for us. And we can use all of these features in conjunction with our CAM environment. So that's important to know when we're doing our setups. So we're going to go ahead and jump on into our CAM environment, and I'll kind of give you just a run through of really quickly about what we have up top here. In our toolpaths, we can choose to simulate, post-process our code for our machine, generate setup sheets for operators in a really timely fashion. It's really important when we're making toolpaths that we simulate it so we can really kind of see what's going on. And then kind of moving from left to right here, we can kind of organize our toolpaths and our jobs with folders, and then create new setups as necessary, depending on what kind of machine we're working on. And then moving along, we have our full drilling, 2D milling, 3D milling, multi-axis, and turning suite for doing all kinds of different parts and on different machines. And then recently, we've also added this 2D profile strategy for water jet, laser, and plasma cutters. How we want to view our part, pretty simple explanation there on when we're working in an environment. And then, of course, our tool library, where we can import, export, make new tools, build libraries, share them between Fusion and HSM. It's pretty handy. So let's get going and start on this part. I've set this part up to be, as Carl mentioned, a mill turn part. I know we're gonna try and concentrate more on the milling side today, but I wanted to show you how we can use both turning and milling, and kind of how they can work together. So this part can be done a multiple different ways. It can be done in a on a multi-axis mill, but really just looking at these features here, these round profiles, this would be better done on a live tooling lathe or a mill turn lathe where the part's actually being spun, and so we can turn these features down and then come in here and mill out these contours. So first thing we're going to do when we do a tool path is we're going to create a setup. So when we do a setup, HSM and also in Fusion, it's going to ask us how we want to define our stock and how we want to define the work coordinate system on the part. So right over here briefly, it asks you what kind of machine you want to select, and it's important to remember that both in Fusion and HSM, it's very self-intuitive. So when you're first learning the program, you'll have these dialog boxes that pop up when you click on an option or an operation, and if you're kind of unsure on what that option is going to do, it gives you kind of a brief explanation. I'm pretty happy with my machine. I'm going to let the program kind of default. Moving on down, I know this is a mill turn operation, so I'm going to go ahead and toggle that on. A lot of live tooling lathes will have dual spindles if you need to work on opposite ends of the part, which is in this case is correct. So in this case, I'm going to hit the secondary spindle because I want to concentrate on this side of the part, as I've already done a setup for this side, and we are going to do a little bit of turning over here, but this is a very simple turning setup over on this side, but we'll focus on kind of the milling and turning on this side so we can get a better description of what mill turning is. And then working on down, we have our ability to set our work coordinate system point, or our Z0 is what it's also known as. And it gives us quite a bit of options for doing that. We can either choose it based on the model orientation, or we can just go ahead and select our certain geometry of the part. And the program's smart enough to know that Z0 is going to run straight through our part, or excuse me, the Z axis. So we'll go ahead and click on that. I want to describe that as my model front, but I want to flip that Z axis so it knows that that's the front of the part that I want to work on. And then moving on down, it's important to know that when we're doing a mill turn setup, that we check that box there that says spun profile. This ensures that anytime we're doing a turned feature, that it's not going to try to get in here and mill out any of these, it's not going to try to turn any of these contours that we want to save for milling, because that's just asking for trouble. So it's going to ensure that when we ask it to do a turn profile, it's going to stick to that only. And then moving on into our stock, Fusion and HSM has a really handy way of being able to describe your stock. With this drop-down menu, we can either choose from a solid. We can choose if we want to go ahead and model our stock and then move it into the CAM environment. We can do that. I usually choose with these default options to pick like a fixed size cylinder. I always like to default to a relative size because then it gives you the option of adding a little more stock. In this case, I want to add about 40 thousandths to the front and the back, just so we have a little extra stock to make a nice clean surface on. So I'm happy with my my post processor, my post name. We'll just leave that for default. I'm going to go ahead and click OK. We've already got our first setup. So now once you set up the stock and the work coordinate system, we can go ahead and start choosing operations that we'd like to do. And the first op that's pretty common in all machining is a facing operation. That's just when we get in raw material, the outside material is dirty, it's gouged, it's uneven. So we want to face that off to a nice clean surface where we can start measuring features from. So in this case, I'm going to choose my facing feature. And then every operation kind of goes from left to right, and it allows you to first pick your tool, your geometry, your boundaries, and your passes. So starting here with our tool, once I click on tool, the tool manager will pop up, and both in Fusion and HSM, it's very flexible on how you can add tools, make tools, import, export. So if you can't find a tool within the default part of in HSM, you can either choose to build your own tool and or actually even create your own libraries as you go along. In this case, I've already created my own tool library for this part. So I'm going to go ahead and click on my facing tool, this 0.8 millimeter turning tool. I'm going to select that. And moving right along to our boundaries, this really describes how we can set up where we want this tool to start and stop. And automatically we know that we want to face off the front of that part. The program is smart enough to know that it's a facing op. We want to bring all that material down just to that Z0. But if we want to take off more, we can always add an offset there as well. And moving right along to our clearances, this is a really handy way to really control the behavior of how the tool enters and exits. Well, actually, as it's transitioning around the part when you're cutting features, this is a really great way to avoid crashing. And again, this is easily interactive, so we can grab this and grab our part and kind of move it in and out and kind of see visually where we want those clearances to be, as opposed to just entering numbers in all the time. I'm going to leave those as stock value because another great thing about Fusion and HSM is a lot of the default values that when you're first starting to create a tool path, they're pretty close to spot on, and you can use those values and then go back and tweak it as you wish. So for passes, you do have the option to have multiple passes on each feature. So in this case, I know I've got that 40 thousandths that I want to take off in the front. I'm going to be generous. I'm going to say 20 thousandths, and it'll automatically calculate the number of step overs based on the width of the step over that I want. And then in linking passes, you can kind of control the in and out of the tool on each feature. So I'm pretty happy with that. And we've already got our facing feature. So we faced off that front face of the stock. And now we can go ahead and start working on that little turn part there, that little turned boss. So we're going to go ahead and click a roughing profile strategy. Again, going to go up here. I'm going to use that same tool that we use for facing. And what I want to do now is I want to tell it that it's an outside profile, not an inside. So it gives us that option. We're going to use that same profile, whether we're doing an inside strategy or outside, but it gives us that option. Moving right along to our geometry. So when we're choosing our boundaries for both milling and turning, it automatically knows what you want to cut, but you want to kind of give it a boundary. So I know I don't want to cut all the way back here. So I want to set, I know my front boundary is at the front of my part, but I want to set my back boundary to exactly where I want to stop that cut. So in this case, I can set my back boundary to that surface. And then when I look at my part on the side, you can see that we're just going to turn that where that highlighted space is. We're just going to turn that boss so we can make room, and I can get in here with that end mill and start turning that contour. So moving right along to our clearances. Again, the stock clearances are usually pretty good. And again, it's all based on the geometry of the part, the tool you pick, and your feeds and speeds. So I'm pretty happy with those. Going right along into our passes. I know I want to go from front to back. This being the front, again, being the front of the part. So I know I want to go from front to back. I usually like to toggle off this axial, or excuse me, this grooving here, this axial grooving and radial grooving. This just tells the program not to do any kind of weird features that it might encounter. Again, this is a pretty simple little boss. We're just going to turn on the outside, but I'd like to toggle that off just so we're not, it's not going to try to do any of this other geometry. And I want to make sure that we can either come down here and we can choose to leave some stock if we want to come back through the finishing tool. I'm going to go ahead and check that off just so we can get a nice visual of what this is going to do. And I'm pretty happy with the lead in and lead out. And there, right away, we already have our first little turning strategy. So let's go ahead and simulate that and see what it looks like. So when we simulate, we can either choose to simulate the whole part, or we can choose to simulate different features of the part. And what's really handy about Fusion and HSM is instead of just playing the whole simulation, I can just come through here. I can just click through to save time, and I can also see what's going on with the part. So right here, it looks like I have a little bit of a crash, but it's really handy when you're analyzing just the lead in and lead out and your clearances. So I'm going to go ahead and fast forward through here, slow this down, and then we're going to go ahead and face off that part, that other end. And then automatically it should start coming in here, and then it's going to turn that down all the way down to that bottom stock, excuse me, that finished profile. And we're looking good. So now once we've turned that, we can go ahead and start working on this outer contour for our milling strategy. Now the cool thing about HSM and Fusion is, again, I can use both these turning profiles, these turning features, and these milling features in the same environment. And when we want to cut out a rough profile or any kind of a contour or any geometry, both Fusion and HSM have this adaptive clearing strategy, which is a really efficient way to engage the tool to its full potential without really adding a lot of excess tool wear. So in this case, the adaptive clearing strategy, it engages the tool at about 40% load. And again, that really ensures that that the tool is getting used to its full potential, and that it's also not going to burn out. It's going to have a lot of life left in it. So same thing with turning. We get to pick our tool, and in this case, I want to just grab my 3/4 inch flat end mill. And one thing to also know in our tool library, when we click on a tool, we can choose to edit that tool. We can edit the holder, the flute length, and any kind of data that we want to throw at the tool, any kind of changes we want to make to it. We do have that option. So I'm going to go ahead and select that. And then moving right along, it asks us to choose our geometry. This could either be a pocket, it could be a contour. That's the really neat thing about adaptive clearing is it's very flexible in what kind of geometry you pick. In this case, I just want to pick that bottom surface, and automatically you can see that this is the direction it's going to machine around. So I'm pretty happy with the rest of these features. I don't really need to go into all of these. This is a pretty simple strategy. And then once again, just like turning, we can describe our boundaries. So when we're either turning or milling, we've already given it a pocket or a piece of geometry or contour to follow. But now we want to tell it where to start and to stop. So this clearance height, I'm pretty happy with. Again, that's kind of where that tool is going to start spinning and then come in here and start turning that profile. But more importantly is our top height and our bottom height. So I know I want this thing. I know I want this contour to start at we'll just say my model top. That way I can bring that in, and it knows that this is the front of my part. And then for my back reference, I know that that's my back reference. That's where I want the tool to end. I don't want to cut any material over here. I have already turned all of this down, but I do want to make sure that that tool knows not to go past that boundary. However, in this case, since I want to make sure that I get a nice clean cut, I'm going to make sure I can offset that back about, let's make that -25. About -25 thousandths. That way, when that tool is going around that contour, it'll kind of clean up that burr, and it'll ensure that there'll be no burrs left. I'm pretty happy with my passes, and since I've measured these radiuses in here, and they're a little smaller than the radius of the tool, so I'm using a bigger tool to come out here and rough with that adaptive clearing strategy, and then I'll come back through with a contour strategy, and I can clean these radiuses up to get my true geometry. So in this case, I do want to have some stock to leave, but if I wanted to toggle this off and just go right down to the geometry, I also have that option. I'm not going to put on multiple depths. I think the adaptive clearing, the default values will work just fine. So I do want to use about 20 thousandths around. I'm happy with my linking passes. So we'll go ahead and see what that gives us. So right away, you can see that it's given us a nice adaptive clearing profile. It's gone to that boundary, which is what we told it to do. So let's go ahead and simulate that and see what we have. Again, I can jump ahead so we can save some time. Jump back here. So after we turn down that little boss in the front, we switch tools. We can speed this up. And that adaptive clearing comes right in there, and it'll mill that out for us. And again, that's just using a very efficient method of clearing out material. We're going to come back through with a finishing strategy to get those radiuses. So I'll close my simulation. And what I can do now is I can go ahead and do another finishing strategy. Let's go for a 2D contour. What this is going to do is it's instead of just moving out material, it's just going to follow that contour we gave it, similar to adaptive clearing, but it's just, we are going to remove material, but it's going to just follow that path, so we can remove the same material. So I'm going to go ahead and select that contour. I'm going to go ahead and give it the same back reference, probably -25. Another thing that is very handy when we're machining, or excuse me, when we're picking toolpaths, and I'll show you here in a minute, go ahead and select that, is that I can also come in here and I can click on, I can make a derived operation. So if I don't want to pick a whole new operation, a whole new feature or toolpath, and I want to use the same tool, same feeds and speeds, I can come in here to 2D milling and choose whatever I want. It's going to pick the same tool, and I don't have to spend time entering in all those extra values. In this case, I'm going to stick with that contour. One thing I did forget to do is, okay, so yeah, so it defaulted. We can leave stock if we so desire, but in this case, I want to come in here with that smaller tool and finish that off. And I want to actually make sure I have the correct tool. I don't want to use that flat end mill. We'll use something a little smaller than that. We could probably use, where is that? Let's see, that 10 millimeter flat end mill. So it's a little smaller. It's a little smaller radius. You're gonna be able to hit these that geometry and finish that off. So we can go ahead and simulate all this. Go right to the end. And there we go. So we've gone ahead and used adaptive clearing to rough out that basic profile, and then we've gone ahead and with that contour, and we finished that off with a smaller tool. So that's kind of how milling and turning works in HSM. I'm going to go ahead and jump on over to Fusion and kind of show you how we can kind of use the same strategies and different multi-axis strategies.
Hey, Nathan.
Also, yes.
I just wanted to clarify a couple of questions came in. This operation you just finished up right there, you kept using the term in HSM. HSM, of course, is the technology that Autodesk has created for the Inventor CAM environment. So
correct,
what
yes.
we've seen now is not HSM, it's been Inventor CAM. So there was the term was used a couple times. We're looking at this in HSM. So it's the same CAM environment. It's just the difference in CAD tools that's there. So
correct. That was my mistake. Yes, we are in the Inventor CAM environment. Both Fusion and Inventor use HSM. So going on into Fusion here, it's a little bit different interface. One thing to know about Fusion is that we already have all of our tools, all of our CAM suite up here, just like in Inventor. But the main difference is that we can switch between environments. So we can switch between the design environment, simulation, manufacturer, and we're pretty much always in the same environment. For instance, if I go to the design environment, none of this model browser data has changed, but down here we have our full work history that we've done to the model. And the really neat thing about Fusion is I can turn a lot of parts on and off as opposed to suppressing a feature. So here in the design environment, I can go ahead and turn off my jaws. I can turn off parts as well, and now I can focus on this part alone, and I can do any kind of design work to it, CAM, and then when I can jump right back in here into manufacturing, it knows that I can just come right back into the models, and I can click my jaws and my vices and things like that. So it's very self-intuitive. It's a lot easier to use, but again, it uses the same interface, again, HSM. So let's go ahead and look at some multi-axis strategies for Fusion. Kind of work on this top part here. I've gone ahead and done the facing op already on this part, but what we kind of want to look at now is a few different strategies to kind of get this more flowing geometry that we have. We know we've got some sloped features here. We've got some curves, and this is going to be better suited for a multi-axis machine. So I've gone ahead and gone with a face operation here, and when I click on this, you'll notice that it's still the same environment. It's still HSM. So we can come in here to into our library. We can select our tools. It's a little bit different than it is in Inventor. One thing I really like about Fusion is that if you haven't built your tool library yet, but you want to start adding toolpaths, it will start to populate and build you a tool library with the part that you're making. So for this particular part, I came down here and I selected a lot of these sample tools that were already given to me in the Fusion library. And then as I was building it, it actually started creating a library as I was making toolpaths. So when I click on this top part here that I'm working on in this assembly, here's all the tools that I've used and I've chosen. So I can actually go in and I can save these as individual libraries for this part. So one strategy I want to look at right now is I've already done a face. So I have my stock sitting in these vices, or in this vise. And let's go ahead and look at how we would do a kind of an adaptive clearing on this outer perimeter of this part. So just like we did in that turn mill part, we can go ahead and select our tool. I'm going to go ahead and use this 1/2" end mill. And again, we can start picking our contours. And once we pick that main contour that we want to cut out, it already knows kind of where our tool is going to, how our tool is going to behave when it's entering and exiting the part. So in this case, this looks pretty good, and I'm going to go ahead and move along into my passes. When we're doing when we're doing an adaptive clearing, it's really handy when we're doing. We can do it on a 3D strategy or a 2D strategy, but it's good to know that you can get a lot done with a 2D adaptive strategy, and even if you don't have a 5-axis machine, I mean, you can get a lot done with just these simple tools in the 2D. So we're going to go ahead and use that rough outside strategy for our adaptive clearing. And again, it uses a 40% load on that tool, just like an Inventor. And the next thing I want to touch on is how we're going to get this top surface here. So we know we've already faced that top part off, so that's already flat. But now we want to focus on this outside geometry here, and we have a couple different strategies we can use. When we drop down our 3D features, we can choose parallel. Scallop is another great feature for this. And what it does is it's going to select a strategy that's going to kind of mold to the part itself, and we can go in and kind of tweak how we want pass to go around the part so we can kind of get a better finish. In this case, I want to go ahead and use a contour strategy. The reason for this is because I know that I've already flattened off that top part right there, but I want it to go around this part. So really the only 3D features that I have are just on the outside of that bounding box. So we kind of come in here to our contour. I've already picked my tool. In this case, it's going to be a ball end mill, so it'll kind of give me a full range of motion as I'm going around the part. And when we're selecting geometry for a 3D contour, we're going to describe it as a boundary. So we know we want to do all the geometry that's within this boundary, but we also want to limit it because we don't want to hit that top. We don't want to hit that top surface. So when we choose the geometry for a contour, we can come down here and we can check this button for avoid and touch surfaces. So in this case, I went ahead and chose that surface right here. And that way, when we go to mill this out, it will only constrict that toolpath to that boundary, and it'll calculate that toolpath for us. So I'm happy with my heights, and then we're moving right along into passes. I'm going to go ahead and leave those at stock value, and we'll kind of see what we come up with. I'll kind of show you how this is going to mill that out. Go ahead and simulate that. So we run through our facing op. We'll do some adaptive clearing on the outside to get our basic shape. And you can see right away that we've told it not to hit that top surface. So now it's automatically calculated a 3D contour without hitting that surface. And there's a couple of different strategies we could use for this. We could use parallel. Right up here, or we could use scallop as well. The reason I chose this 3D contour is because, again, it's a pretty symmetrical part, and again, we've already faced that top feature off, and so that's the best feature for this. Using the best tool operation for this particular feature. Another thing I want to emphasize is that when we're dealing with passes, we can look at this maximum step down. This is going to really determine what kind of finish we want to get. So there are quite a bit of different selections that we can have, but it's important to know that when we're making toolpaths in HSM, is that the default values will give you a pretty good result, and then you can go back and tweak how you would like this. So say we don't want this part to run so long. Let's try to up that to 2000 step down. And then that'll regenerate. And we can kind of zoom in here, and we can notice that these step downs are a little wider. So that's one way that you can use a 3D strategy when working with Fusion. We can also go into drilling operations, and I want to show you how we can use boring and drilling. So in this particular part, I chose a boring operation just because these were a little bit not just a standard size. So I'm going to go ahead and leave that alone, but I want to show you how we can come in here to a drilling operation. And when we're choosing our points to drill in, we have this option to select same diameter. So when we're picking a drilling operation or a hole, anything like that, we can either choose to pick these individually, or we can hit same diameter, and it will automatically recognize that yes, we have the same hole and it will create that toolpath automatically, which is exactly what I've done here. So I've gone ahead and I've counter drilled those holes. I bored them and counter drilled them, countersunk, and then I've come in here and I've drilled those out. But all I've had to do is select these faces and then hit same diameter. It's automatically generated those holes for me. So when we're working in this Fusion CAM environment, it's really handy to know that, again, we're working in an environment that's kind of all inclusive. So let's say I want to do this top part, but I want to switch to this bottom part. So all I have to do really is come up here to my models, click on that bottom part, turn off my top part, and I'm ready to start doing setup on that. So it's really handy when you want to save time and you don't want to be moving data around so much. One last thing I want to touch on is really ways that you can kind of hot rod your Fusion environment when you're working in Fusion. They're not just, you don't have to use the same features all the time. You can come in here and Fusion does offer several different extensions that you can add on to your CAM, 5-axis collision avoidance, hole recognition, rotary strategy when you're doing kind of complex shapes, and just a lot of different features for really getting the most out of your CAM experience. So that's all that I have for you guys today.